Hello, this is Miss Richards, and this is a crash course on heat transfer. So the first thing you want to know about heat transfer is that heat always goes from warm areas to cold areas. So the saying that you're letting the cold air in when you open a door in the wintertime is technically false because you're letting warm air out. The first type of heat transfer is convection, and this is the movement of heat through air or liquids, which we can group together and just call fluids. So warm fluids become less dense, the particles spread out more, and that less dense fluid rises up, while cooler fluids sink, and it creates this cycle, like a current. So in the diagram to the right, we have, let's just say, a pot of water on a hot stove. So the water at the bottom is being heated, and as that happens, it becomes less dense and rises up. While it rises, cooler, more dense water is sinking to the bottom. Once there, it gets heated most directly from the burner beneath the pot, and then the cycle just continues. Hot water rises. Once it gets to the top, it begins to cool and then sinks back down. More examples of convection would be, boiling water, a hot air balloon. So there's an actual burner that heats air that controls how high the balloon rises because that air is caught in the balloon itself. So as you let the air cool, the balloon sinks back to the ground. As you heat the air up, the balloon rises. Currents and wind, so you can see in this diagram warm surface flow of water currents, so on the surface means less dense, rising to the top, and cool subsurface flow would be the more dense water at the bottom. Baking food, it's all about heating air. So that air circulates around the food, it heats the metal tray that's in there, it heats the pan, and it heats the food itself. And then lava lamps. You may or may not have experienced these. They're kind of old-fashioned now, but this gooey lava substance rests at the bottom, and as it's heated, it rises to the top. And then once it's at the top, like in this picture, it's away from the heat source, it cools down a little bit, and it'll sink back below and get reheated, and it's a bunch of bubbles that are constantly being heated and rising and then cooling and sinking. The second type of heat transfer is conduction, and this one's pretty straightforward. It's all about direct contact with another object. So this burner is using, radiation and also some direct contact to heat this bar. The person holding the bar eventually is going to burn their hand once the bar heats up enough because of that direct contact, the conduction. So touching a hot bowl would be an example of conduction. You have that direct contact between the soup and the bowl and your hand. Cooking food in a frying pan because that food is sitting directly on the pan. Ironing clothes, the iron is touching the clothes. And holding an ice cube in your hands. Eventually the thermal energy from your hand is going to go into the ice cube and it will start melting. But you are actually touching it, and that's what makes it conduction. Last but not least, we have radiation. This is the transfer of energy through matter or space as electromagnetic waves. And fire is a very good example of radiation. It can travel through a vacuum or empty space, so it doesn't actually have to enter into particles. It just spreads no matter what's around it. More examples. So the electromagnetic spectrum has many different types of waves on it, and these are just a few of the ones that you actually interact with. So over on the right we have X-rays. X-rays are a form of radiation. Heat travels through empty space and through matter. Ultraviolet waves, that's the thermal energy transfer from the sun. Ultraviolet waves are part of the electromagnetic spectrum. Visible light, the one that we're used to. Infrared radiation, so that would be like thermal imaging. And up here we have fire, which is a combination of the two. So infrared is what we feel as heat coming off of the fire, and then the visible light is from the brightness when we use fire to guide our way. Microwaves, kind of self-explanatory. They're called microwaves. They're used in a device that we call a microwave. And the same goes with radio waves. Radio waves are travel through radiation. They don't have to penetrate matter. And that is the overview of thermal energy. I hope this helped, and if you have any further questions, please contact your teacher.